All right, so Charles' law, we're going to compare volume versus temperature. So that is the original Charles' law. Is that V1 over T1 is equal to V2 over T2. So this looks like one of them. Which one does this look like? Boyle or Gay-Lussac? Gay-Lussac, okay. What do we do to Gay-Lussac to make it easier to deal with? Cross multiply. So we're going to cross multiply the temperatures. And so we're going to end up with V1 T2 equals V2 T1. And so that's the one we're going to deal with for Charles' law. It's just easier to manipulate when we get to that phase. So we got V1 T2 equals V2 T1. So go ahead, take your 45 seconds, a minute, figure out your four variables. So I want an equation for V1, I want an equation for V2, or a formula I should say, T2, and T1. So if I'm solving for V1, what do I need to write first? V2, T1. I'm writing the other side, and then I ask myself, how is T2 connected to V1? Multiplication. To get rid of it, I'm going to divide. Same with V2, I'll write V1, T2 divided by T1. Then I got V2, T1 divided by V1. And then I've got V1, T2 divided by V2. And so there are your four formulas to manipulate or to use in this formula. Now, or this law. What are going to be our rules then as far as units are concerned? Has volume ever mattered? No. I can use it in milliliters, I can be in liters, I can be in gallons, I can be whatever I want to be, as long as what? They're the same. They agree. Temperature needs to be in what? Kelvin. How do you get into Kelvin? Celsius plus 273 equals Kelvin. All right, I will do one just to help you out. Alright, so the balloon has a volume of 0.50 liters of gas at 25 degrees Celsius. What will be the new volume of gas at 110 degrees Celsius? Alright, before we get into this, let me talk, I know there's one more thing I want to talk about, because here's where people think incorrectly. So, I got a balloon. If I have a balloon, and I blow air into it, what am I blowing into it? Carbon dioxide. Okay? Pressure is increased, correct? Why is pressure increased inside of this container? Say it louder, Belle. So I put air into it. I've now increased the volume of gas in here, correct? Okay. Now I've got some gas in here already. What's going to happen if I put more gas into it? So that's my pressure. It increases. How else could it increase the volume of gas inside here without actually putting more gas? Heat it up. Okay? So understand that when we're talking about the volume, we're talking about the volume of gas. Now if I put this volume of gas into my huge tub back there with my snake, okay, that's a 40-gallon tub. That's what he's in, or she's in. If I put that gas in there, would the pressure be the same as it is in this little balloon? No. I put it into a bigger volume, because that's where people are going to get confused or maybe misinterpret some things, is that you can have the same amount of gas and put it into a bigger container and the volume changes. Remember, is the volume of gas definite? It's indefinite. Okay? So I can increase the volume of the gas by putting more gas into it, or I could also put it into a smaller container, also increase the temperature, or I could the temperature, increase that. So all different kinds of ways I can increase the pressure, volume of gas. I'm not going to blow it up this time. We're going to do a lab probably tomorrow or the next day, putting all this together. So I wanted to be clear on that. We're talking about the volume. We're talking about the volume of the gas. Now, let's start getting all this labeled. So, a balloon has a volume of 0.50 liters of gas at 25 degrees Celsius. So, what is 0.50 liters? The volume. So V1 is equal to 0.50 liters. Okay? And then, so what does that make 25 degrees? Temperature 1, because it's at that volume, it is this temperature. Okay? So what will the new volume be at the gas at 110 degrees Celsius? So what's that measuring then? T2. And then what am I looking for? P2. V2. Alright, so we had V1 T2 equals V2 T1. So that's going to be V1 T2 divided by T1. So plug in the numbers and I get the answer, right? What I got to do? So I'm going to add 273 plus 273 and then plug in my numbers. All right, so let's proceed. I should know that one. I do that one all the time. All right, how many stick figures should I have? Why 2? All right, I got 2 here. I got 2 here. I got 3 here. So my answer should have 2 stick figs in it. Do all my math. I should get 0.64. All right, 0.64 what? Liters. There's your answer. Let's go.
Worth fixing?
Yeah.
Okay. Whenever you get a second.
Don't creep on me like that. I ain't lying.
You're not responsible for what you'll do?
No, and I'm about to be online in about 4 seconds.
But it would be entertaining. The kids would be entertained.
Yeah. Any questions?